Good evening. Yes, follow me. Uh, Please tell your friend to join. Okay. So follow me. I see your partial, your homework. Actually, you just find critical value or critical values at 1% and 5% level, and then compare with your observed value. And actually, I mean to say find critical value. Okay. At 1% level and 5% level. You can find this critical value uh, from your book. Okay. Then compare this critical value with observed F, and then if observe F, first you see the interaction effect. If observe F less than critical value, then proceed further, because uh, if observe F less than critical value, then interaction effect is insignificant, then proceed further. Otherwise, otherwise means if observe a greater than critical value, then you say interaction effect is present and stop. Okay, you understand? Please tell me. Follow me. Are you hear me? So please tell me. So okay, today I am going to discuss random effect model first. Random effect model. Okay, thank you. Follow me. As we know, if both the levels of A and the levels of B are random sample, actually I already mentioned that fixed effect model when we consider all the labels. Okay, but some situation it is not possible to consider all the labels. We consider, then that time we select some labels from this whole label. So this situation is called random effect model, because that in that case the labels are not, effect of the labels are not fixed. This is random. For example, suppose we have a 4 types of variety, then if you can, it is possible to consider all the varieties. Okay, I already give the example. if you go through the previous class, then you can find when you use random effect model and fixed effect model. Fixed effect model possible when you consider all the labels, but if but when you consider some labels from whole labels, suppose you have a p label, but size of p is huge. So in that case, you select some labels from p labels. In that case, then we consider random effect model. Here, follow me. Please see the uh, previous classes. Then you can find I give lot of examples. Okay. Please tell me, are you understand? Follow me. Okay, thank you. If both the labels of A and labels of B are random sample from a large number of labels, then in the main effects and the interaction effect are not fixed, quantities, but they are random variables. And so the model is random effect model. For example, in which such a model might arise, suppose that there are p machine and few workers. In the experiment, and each worker is assigned to each machine for m days. Further, so up to that, if you consider all P machines and Q workers, if it is possible, in that case it is a fixed effect model. But further, if the P machines are a random sample, that means there are more than P machines, okay, but you select only P machines. So in that case, P machines are random. P machines are a random sample from a large population of nations, and Q workers are a random sample from a large population of workers. So for random effect model, both the labels are random, okay. So this is the criteria for random effect model for 2A Anova, okay. So, and if both the labels are fixed, that means if you consider all the labels of factor A and all the labels of factor B, then it is a fixed effect model. If all the labels of factor A and all the labels, if you select some labels of factor A and some labels of factor B, then in that case these labels are random, so it is a random effect model. So this is the difference between fixed effect model and random effect model. Now the model Yijk mu plus, since it is random, instead of alpha I write ai, bj, instead of beta j I write bj, cij, this is also random, interaction effect also random, eijk, where ai, bj, cij are completely independently normal with zero mean and respective variances are or respective variances sigma a square, this is for ai, sigma b square, this is for bj, and this is for interaction, okay. And also eijk follow iid normal 0 sigma m square. And I denote this model by omega hypothesis. We wish to test HA sigma square equal to 0, sigma v square equal to 0. These are all null hypotheses. So the alternative hypothesis should be not equal to 0. Analysis. Here we use for here we use 4 SS sum of squares, that is SSA, SSB, SSAB, SSE for main effects of A, main effects of B, AB interaction, and error. Are defined in terms of observations. Yij are the same as the fixed effects model. That is SSA. I just recall the SSAs are of fixed effect model. SSA sum of square due to vector A, which is un sum of I yi not bar y not bar whole square, SSB em j y naught j naught bar minus y naught bar whole square, SS AB m sum over I sum over j yi j naught yi naught bar y naught j naught bar plus 2y naught bar whole square, SSE sum of square due to error, that is ijk yijk minus yi j naught bar whole square. Now the model is Ijk. Instead of Yijk, this is mu plus Ai Bj plus Cij plus Eijk. Now replace Yij by this. Then recessive equal to Qn sum over I Ai plus this is B naught bar plus Ci naught Ei naught bar. I forgot to write this part also, mu plus. Okay, so minus y naught bar, this is equal to minus mu minus E naught bar minus B naught bar minus C naught bar minus E naught bar whole square. So this is equal to Qn sum over I Ai Ci naught bar plus Ei naught bar B naught bar minus C naught bar minus E naught bar whole square. So similarly, you can write SSB, which is equal to Pn sum over J Bj plus C naught J bar plus E naught J naught bar minus B naught bar minus C naught bar minus E naught bar whole square. SSAB, which is equal to N sum over I sum over J Cij minus Ci naught bar minus C naught J bar I think it is only Y naught. Please change this part. Okay. SSAB, the first part, this is part 1. You see that I wrote Yij naught minus Y naught, Yi naught bar, Y naught J naught bar plus Y naught bar, Y naught 2 into Y naught bar, but it should be Y naught bar plus Y naught not 2. Please delete this 2. Okay, thank you. Eij naught bar minus P naught naught bar plus Eij naught bar minus Ei naught naught bar minus E naught J naught bar plus E naught naught bar whole square. And SSC equal to equal summation Ijk Eijk minus Eij naught bar whole square. Now let Gi, which is equal to Ai plus Ei naught naught bar plus Ci naught bar. This follows IID normal 0 sigma G square, where sigma G square, this is equal to, you can check this thing, okay? Sigma A square plus 1 by Q, just variance of Gi, okay? And since Ei not Eij Ei are independent, so cop parts are in 0, okay? Covariance part are 0. So variance of Gi, which is variance of Ai, this is sigma square, variance of Ei naught naught bar, this is equal to 1 by Qm sigma square plus this is variance of Ci naught bar 1 by M sigma AB square, not 1 by M, 1 by Q, sorry, 1 by Q sigma AB square, because it is on J. Ci naught bar is nothing but a 1 by Q sum over J from 1 to Q Ci. So it should be 1 by Q sigma AB square. Okay. Since these are independent from these assumptions, so covariance part should be 0. So I rewrite this once again. Sigma A square 1 by Q sigma AB square plus 1 by Qm sigma A square. Hence, SSA, which is equal to Qm sum over I from so see that these terms are cancelled out. This is also so I from 1 to P. So this should be I plus Ci naught bar plus Ci naught bar, which I denote by Gi, and remaining portion is G bar. Okay. So from the sampling distribution of if you use orthonormal transformations, because here we see that GIs are now IID normal with 0 mean variance, constant variance, that is sigma G square. So we use orthonormal transformation. Then and if you look at this form, this is nothing but a n minus 1 s square, this type of things. Okay, so this follows from using orthogonal transformation, follows chi square with degrees of freedom p minus 1 into sigma E square into this QM term, because these portions, if you look at this portion is nothing but a p minus 1 s square this. So these portions follow chi square with p minus 1 degrees of freedom into sigma g square, and for this we need to add qm into sigma g square and chi square p minus 1. So SA follow, I rewrite this again. This is qm because of this term, and for this term this is sigma g square chi square with p minus 1 degree of freedom. So therefore expectation of SA, which is equal to qm sigma g square chi square sigma g square p minus 1 degree. So sigma qm, because of chi square, we know expectation of chi square p minus 1, which is p minus 1, and then sigma g square. So we look at this, this is also, if it is if when A is a levels of A is a fixed or a fixed effect model, then SSA follow non-central chi-square distribution. But here for random effect model, SSA follow some constant into central chi-square frequency. This is the another difference. Okay, Paul, please note down these portions. For random effect fixed effect model, SSA follow non-central chi-square distributions, but random effect model follow some constant into central chi-square distributions. Okay, please write this thing. This is another difference. So expectation MSA, this is equal to SSA by P minus 1. So this gives QM sigma G square. Now look at the expression of sigma G square. This is equal to sigma A square plus 1 by P sigma AB square plus 1 by QM sigma A square. So sigma G square is nothing but a, if you replace this, if you sigma G square replaced by this term, then you get QM sigma square M sigma AB square plus sigma E square. Okay. So we can I rewrite this again, sigma E square M sigma AB square plus UM sigma E square. Similarly, expectation of MSB, this is equal to sigma square M sigma AB square plus EM sigma B square. So this is your homework, please check. Now let Hij j, which is equal to Cij plus Aij naught bar, this is follow IID normal 0 sigma square h, where sigma square h, this is equal to sigma AB square, because of variance of sigma ij equal to sigma AB square, plus sigma E square by m. This is the variance of Eij not bar. And since Cij and Eijk are independent, so covariance part is 0. So therefore, if SSAB, we look at the expression of SSAB, which is equal to m, if you replace this part by Hij, so this is equal to Mij Hij minus H Hi H naught J bar, because this is a Cij, so I think it is better to look at these portions. Okay, so this is a Cij plus Eij, okay, Cij plus Eij. So if you look at these portions, then you see that Hij minus Hi naught minus H naught J plus H naught naught whole square. Okay, so these portions look like SSC sum of square due to error for one observation parcel. So using these observations, you can write this follow m into this follows from the, because this look like a SSC, just see the expression of SSC sum of square due to error for 2A Anova one observation parcel. So this portion follows chi square with degrees of freedom, that should be the degrees of freedom of error degrees of freedom of 2A Anova one observation parcel, that is P minus 1 Q minus 1. Okay, sigma H square into sigma H square. So I write this in that way, that is m into sigma H square chi square P minus 1 Q minus 1. Okay, follow me. Have you any trouble? Please tell me. So except follow me, if there is anybody watching this video, you can also write your comment on the comment section. So please tell me, follow me, are you understand? Just look at the expression of SSC sum of square due to error for 2A Anova one observation parcel. Then you see that these are the same thing. Instead of Hij, where you write Eij. So no problem. So you can use this, use the result, because SSC sum of square due to error for 2A Anova one observation parcel follow chi square constant into chi square with degrees of freedom p minus 1, q minus 1. So it is with this pack you can write this follows SSAB follow m into sigma hs square. Instead of sigma e square I write sigma m into h sigma hs square and into chi square p minus 1 p minus 1. Thank you. So therefore expectation of SSAB, so this is equal to m sigma h square expectation of chi square p minus 1 p minus 1 degrees of freedom. This is equal to m into sigma h square p minus 1 into p minus 1. Okay. So expectation of MS AB, which is equal to expectation SSAB by p minus 1 q minus 1. So this is equal to m into sigma h square. Now look at the expression of sigma h square, which is sigma ab square plus sigma e square by m. Then it should be m sigma ab square plus sigma e square. Similarly, further you can find, this is your homework, MSc, which is equal to sigma square. Please do it and then submit. This is your homework. So you have a two homework, this. So test criteria, real and testing process. Under HA, sigma square equal to 0, then we see that expectation of MSA, look at this expression, equal to, since sigma square is 0, so this is nothing but a expectation of MSAB. Okay, so expectation of MSAB, MSA equal to expectation of MSAB when HA 2. So hence for testing this, the valid error is MSAB. Okay, please note down for me. When you want, when for testing HA, the valid error is MSAB. This is the another difference between fixed effect model and random effect model. For fixed effect model, MSA is always the valid error, but for random effect model, for testing HA, the valid error MSAB, but for fixed effect model, it is always MSC. So And when HA is false, expectation MSA, which is greater than expectation MSAB. Then the ratio FA, which is MSA by MSC, will give, sorry, MSAB, MSAB will give the test criteria for testing HA. Note that FA, which is MSA by MSAB, follow a distribution P minus 1 into P minus 1 degrees of freedom under HA. Even if under alternative, that is when HA is false, this is also a distribution. So this is the another difference. Please note down. This is the another difference between fixed effect and random effect model. Fixed effect model, when HA is false, in that case this is a non-central F distribution. But here this constant into central F distribution. So please note down this point also. This is the another difference. So if similarly HB is rejected, at alpha level of significance, if AB is equal to MSB by MSAB, greater than F alpha Q minus 1, Q minus 1, Q minus 1. If m greater than 1, we can make inferences about sigma square AB by using the ratio FAB MSAB by MSA, which is follow sigma square m into sigma AB square by sigma square into F P minus 1 Q minus 1 PQ M minus 1. But for fixed effect model, this is not a central A. This is the another difference. Okay. Under model omega. When HAB is true, then FAB is equal to MSAB by MSC. This follows central A, P minus 1, Q minus 1, PQ, M minus 1 degree of. We reject HAB if observed greater than if alpha P minus 1, Q minus 1, PQ, A minus 1 degrees of freedom. So you note that for random effect model, when you interest for testing HA and HB, that is main effect, then the validator is MSAB. And for testing interaction, that is HAB, that is sigma AB square equal to 0, in that case, validator is MSE. So this is the difference between fixed effect and random effect model, because in fixed effect model, MSE is always a validator. Moreover, in particular section, we observe that if always this ratio, F ratio, always follows central F distributions. Even HA is true or null is true or false. But for fixed effect model, for alternative, when H null hypothesis is false, then it is a same non-central F distribution. These are the difference. Please note down. Now consider Anova table. The first column is source of variance, you know it. Source of variation. Second column is degrees of freedom. Third column is SS. Fourth is MS. And last one is F ratio. So due to first entry is due to factor A, second is due to factor B, due to interaction effect AB, due to error. This is total. This is P minus 1, this is Q minus 1, this is P minus 1 into Q minus 1. This is PQ M minus 1. This is PQM minus 1. Just write the expression. I just write SSA. Please you write also the expression of SSA here. SSB, same thing. SSAB, you do same thing. Just expression, that is for SSA it is QM, sum over I from 1 to p yi not bar minus y not bar whole square. Similarly, write all expression, that is SSB, SSAB, SSE equal to, and SST, this should be, double triple summation yi jk minus y not r whole square. Now MSA, this is equal to SSA by p minus 1, MSB, this is SSB by q minus 1, MSAB, this is equal to SSAB by p minus 1 q minus 1, and last MSE, which is equal to SSC by PQ m minus 1. F ratio, FA, this is equal to MSA by MSAB, FB, this is equal to MSB by MSAB, FAB is equal to MSAB by MSC. Remark. In our model, sigma a square, sigma b square, sigma ab square, sigma a square are unknown. Are unknown quantities. And their unbiased estimated are sigma a square hat, this is equal to ms a by ms a minus ms ab by un, sigma b hat square, this is equal to ms b minus ms ab by pq, sigma ab hat square, this is equal to ms ab minus mse by n, and lastly sigma e square, this is equal to mse. So these are the unbiased estimators of sigma e square, sigma b square, sigma b square, sigma e square. You can verify this from the expression of expectation of MSA, expectation of MSA, MSB, expectation of MSAB, expectation of MSC. These are already I discussed in my previous lecture for one-way Anova random effect. So please check this expression. So please tell me, can I continue mixed effect model or stop here? Follow me. Please tell me, can I continue? Follow me. Should I continue? This is mixed effect model. Okay. mixed effects model. An example of a two-way layout in which it is appropriate to treat one of the factors as having fixed effects rather as having random effects. Can be obtained by modifying the example concerning machines and workers so that the workers are still regarded as a random sample from the large population of workers the machines are not. The interest being the individual performance of the machine. So here one factor is random and another factor is fixed. So that's why this is called mixed effect model. So for this example, here I consider worker as a random effect model, consider the random variable, effect of worker as considered as a random variable, and but the machine here is fixed. So this is the example of mixed effects model. Let Yijk be the kth observation when jth workers jth worker is working in the ith machine, where I from 1 to p, that means we have only p machines, j from 1 to q. We select q worker from a large number of workers, and k is k from 1 to n, because each combination contains m observations. So therefore the model is yijk mu plus alpha, because machine is fixed effect here, pj because worker is random, cijk because interaction is still random, eijk, where summation I from 1 to p alpha I this is equal to 0, summation over I from 1 to p, this is for fixed effect model Cij. This is for fixed effect, summation I from 1 to p Cij equal to 0. For all j, the j, Cij, Pijk are jointly normal. The Pijk are independently normal 0 sigma square and independent of Vj and Cij, which have 0 means, and they are not independent. I denote this by omega. Define sigma I square, which is equal to 1 by p minus 1, sum over I from 1 to p alpha square, sigma b square, which is equal to variance of Vj, sigma ib square, which is equal to 1 by p minus 1, sum over I from 1 to p variance of Cij. Analysis. Here we shall use the sum of squares Sx which are obtained in two-way fixed effect module, if we substitute the module into four SSS, defined in fixed effect module, we get SSA which is equal to, we know QM, sum over I from 1 to P y naught naught bar minus y naught naught bar whole square equal to QM sum over I from 1 to P alpha I Ci naught bar plus Ei naught naught bar plus Ci naught naught bar, sorry, there is a problem. Okay, issue. So this is equal to Qm sum over I from 1 to P alpha I plus Ci naught bar plus Ei naught naught bar minus C naught naught bar whole square. SSB which is equal to Pm sum over J from 1 to Q y naught J naught bar minus y naught naught bar whole square equal to Pm sum over J from 1 to Q Bj plus E naught J naught bar minus B naught E naught naught bar whole square. SSAB equal to M sum over I sum over J, you can check this thing Cij minus Ci naught bar plus Eij naught bar minus Ei naught naught bar minus E naught J naught bar plus E naught naught bar whole square. And SSC equal to double summations, triple summation, sorry, Ijk, Eijk minus Eij naught bar whole square. Since Ci C naught J bar, this is 0 for all J, imply C naught naught bar 0 because these are assumptions. So these are okay. So these four SSS are pairwise independent except for the pair SSB SSAB. We can check this. This is another homework. We have SSC. This is follow sigma square chi square PQ m minus 1 degrees of freedom. This is another homework. Check this using the argument, using the previous argument of random effect, fixed effect. You can easily argue this follows chi square sigma square chi square PQ m minus 1 degrees of freedom. Therefore, expectation of SSE, which is equal to sigma square PQ m minus 1, hence expectation of MSE, which is SSE by PQ m minus 1. So therefore, expectation of MSE equal to sigma square. Hence, MSE is an unbiased estimator of sigma square. Let Fi equal to Bj plus E naught J naught bar, we get SSB, which is equal to Pm sum over J from 1 to Q Fj minus, this is Fj, okay, Fj minus F naught bar whole square, where Fj follow IID normal 0 sigma F square with sigma F square equal to sigma B square plus sigma E square by Pm, and SSB, therefore SSB follow using the same argument Pm sigma F square chi square Q minus 1 degrees of freedom. Therefore, expectation of SSB, which is equal to Pm sigma F square Q minus 1. So Pm Q minus 1 sigma F square means sigma B square, sorry, this is small b, not capital B. Okay, no, it is a capital B because of these notations. Okay, so sigma B square plus sigma E square Pm. So therefore, expectation of MSB, which is equal to expectation of SSB by its degrees of freedom, that means Q minus 1. So this is equal to Pm plus Pm sigma B square plus sigma E square. It is convenient to define alpha I hat equal to yi naught bar minus y naught bar, so that alpha I hat is equal to alpha I plus ci naught bar plus ei naught bar minus e naught bar, and hence expectation of alpha I hat, this is alpha I, and variance of alpha I hat, which is equal to variance of alpha I hat, which is equal to 1 by q variance of Cij plus p minus 1 in p sigma square. Please check, this is your another homework. Hence, expectation of SSA, which is equal to expectation of Qn sum over I from 1 to q alpha I hat square into is equal to p minus 1 in sigma b square plus p minus 1 sigma e square um sigma a square. So this is your another homework. Please check. So this implies expectation of MSA, which is equal to sigma e square m into sigma ab square plus um sigma a square. Similarly, expectation of MSAB equal to sigma e square plus m sigma ab square. So this is your another homework. Please do it and submit. Now the test criteria. And testing procedures. So if n greater than 1, note that expectation of MSB equal to MSE if HB sigma b square equal to 0 is true. So see that for testing HB, the valid error is MSE. We also observe that for random effect model, this is MSAB valid error. Again, for fixed effect model, this is MSC. So random fixed effect model and mixed effect model, for testing HB, the valid error is same, that is MSC. But for random effect model, it is changed and it is MSC. So this is the difference. Please note down these portions. Okay. So this is greater than MSE if HB is false. The ratio FB, this is equal to MSB by MSC. Please follow. F distribution Q minus 1 PQM minus 1 under H naught under HB. Okay, will give a test form, a test statistics form. HB. So here also you observe that FB is a non-central F distribution when HB is not true. This is for fixed effect model and mixed effect model, but random effect model, this is always central F distributions, whether HB is true or false. Next note, the hypothesis HAB sigma AB square equal to 0 is tested using ratio FAB equal to MSAB. This is same for all three effects, because all three effects the valid error for testing HAB same, that is MSE. So please note down this thing. P minus 1, Q minus 1, PQ, M minus 1. Sorry. Under HA. So note that expectation MSA equal to expectation MSAB and greater than expectation MSAB. So under HA. Under HA. That is sigma square equal to 0. And this means all alpha is equal to 0 for all, because this is a mixed effect model and factor A, we consider all the labels of factor A. So sigma is square equal to 0, this is same as alpha equal to 0 for all. So here we observe that the valid error for testing HA is MSAB. So please note down, for random effect model and mixed effect model for testing HA, the valid error is MSAB. But for fixed effect model, the valid error for testing HA is MSE. Okay. And this is greater than when HA is false. Hence, the ratio FA, which is equal to MSA by MSAB, will provide a test for HA even though MSA and MSAB are independent, and under HA FA does not in general have F distributions. An approximate F test with p minus 1 into p minus 1 degrees of freedom. So this is the another difference for random effect model and fixed effect model. If a follow either central F distribution when it is random effect model, and non-central F distribution when it is mixed effect model. And both the cases, fixed and random, this follows central F distribution with H is true. But here we observe that this F ratio is not a F distribution, but we can approximate this by a F distribution with p minus 1 to p minus 1 degrees of freedom. So please note down this portion. So an approximate F test with p minus 1 into p minus 1 degrees of freedom may be performed for HA with the ratio FA equal to MSA by MSAB. So now consider the Anova table. So first column is source of variation. Second column is degrees of freedom. Third is MS. Okay, you can write SS also, sorry, SS. Third is MS. Fourth is expectation of MS. And last one is F ratio. Please complete this table. This is your homework. As before, you can, I think you can complete this table. Okay. So this is your homework. So you write it. One thing I can help you, due to factor A, this is fixed. Due to B, this is mixed. AB interactions. This is error. And last one is total. So this is P minus 1, you know, Q minus 1, PQ, P minus 1 into Q minus 1, PQ M minus 1. The last one is PQM minus 1. SSA, write the expression. SSB, write the expression. SSAB, write the expression. SSE, write the expression. SST. MSA, MSB, MSAB, MSC. Also write the expression of expectation of MSA, expectation of MSB, expectation of MSAB, expectation of MSC. Then F ratio FA equal to MSA by MSC, FB equal to MSAB, MSB by, this is MSB by MSC, and FAB, this is equal to MSAB by MSA. Okay. Remark. We have expectation MSB, which is equal to sigma square plus Pm sigma B square. Expectation of MSAB, which is equal to sigma square M sigma AB square. Expectation of MSP, which is equal to, this MSC, which is equal to sigma square. They are usually valid. They are as usual valid without normality assumption. They lead to the following unbiased estimators if m greater than 1. That is, we can easily find using the expression of expectation MSA, expectation MSB, expectation MSC. Okay? 1 by Pm MSB minus MSC sigma AB square hat, which is equal to 1 by MS AB minus MSC sigma square hat, which is equal to MS. So this is your homework. First homework: compare three models. Compare three models: random, fixed, random, mixed, for with respect to two-way Anova, more than one observation pass. This is your first homework. Second homework: suppose we consider example. There are P given varieties of price of the productions of which are experimented in few Indian districts chosen randomly. Here we are interested in the interaction effects. Along with the main effects, so write a model at the appropriate model in detail. I can write, I read this. There are P given varieties of rice of the production of which are experimented in Q Indian districts chosen randomly. Here we are interested in interaction effects along with main effects. Write appropriate model in details. This is your second homework, and first homework to compare the models fixed random mixed with respected to Anova more than one observation per se. Okay, these are the homework. I already also give another so many homework in this class. So please do it all the homework and submit within a week. Okay. So if you have any queries, please tell me. I want to end this thing now. Thank you. Have you any query? Next Monday, we will start regression analysis. So, have you any queries? Please tell me, follow me. If you're watching the video, please tell me, have you any queries? Follow me, or anybody who watches this video, please tell me, have you any queries? So one thing I mentioned, those who not subscribe this channel, so they cannot comment. Okay, so for chatting you should subscribe before you subscribe, then you chatting. Otherwise you cannot comment. So this is follow me. Can you hear me? Please tell me, have you any queries? Otherwise I will end the stream. So I think we have no question. Okay. Thank you for watching this video. We will meet again on Monday. Same time, 6 p.m. Thank you.